Welcome to the Engineering Numerical Methods, Module number 5, Numerical Differentiation. So our goal in this video is to present to you the numerical method on differentiation. So the statement of the problem or the problem can be summarized into this statement. Given the function f of x, compute the n degree or n order function or d to the n of the f divided by the dx of n at any given x. So meaning we're looking at the differentiation of the nth degree of the function. Okay, so here we would like to use the differentiation by interpolation or curve fitting. So this module of the interpolation and curve fitting is actually the same as module number 3. Okay, so if you're not familiar with this, so you can look at module number 3. So numerical differentiation provides a means to obtain the derivatives at the point x is equal to x of t, okay, given the function y is equal to f of x. Okay, so in this example we're just going to discuss the first the next derivative, okay, or the next order derivative. So if you wish to continue the derivatives from a set of discrete points xi and yi, so these are the coordinates where I is a certain data points or the range of the data points, numerical methods perform first an interpolation or curve fitting to determine the curve that can represent the points. Okay, so meaning we can create the points. For example, in this diagram here we have a set of points 1, 2, 3, 4, 5, 6, 7. So we have 7 points, and then this curve, the blue one, okay, serves as the line or curve that represents these points. Okay, so you can understand the behavior of that system expressed by that points or discrete points. Now, so as I said, if you want to go deeper to the interpolation and curve fitting, so I'm inviting you to check the module number 3. Then the differentiation happens by deriving the best fit curve based on its coefficient. Okay, so basically we would like to know the coefficients of the polynomial. In this case, we're going to use the polynomial. So before we go to that, let's try to understand how an example of the derivatives by interpolation or curve fitting. So here, a vehicle speed sensor collects discrete data points, okay, so time and also the velocity or the speed. So we have the time, okay, or t serve as a timestamp or time index, and while v of t as the instantaneous speed at time t. So differentiating the data points for a certain time t will give us the acceleration a of t given by the vehicle at that instant time t. So here, this is the illustration of this example. So you have 7 data points for your velocity or speed, and first thing first, I mean there are two steps. First, we create the line or the curve that fits or best fit the data points. Okay, so we have this blue line here, solid blue line, and then after that we derive that line, okay, using the coefficients of this line. So this line can be expressed by polynomial, and we know that the polynomial can be expressed by a number of coefficients, and then we can get the derivative by looking at the coefficients of that polynomial line, okay, or polynomial curve. Okay, so basically there are just 2 steps: fit the data points and then get the derivative of that curve. So those are the two steps for getting the uh, fit the data points, and then derive the fitting curve. Okay, so basically that's it for the derivatives by interpolation and curve fit.